이번 동영상은 멀티플 랜덤 베어리블스에 대해서 논하겠습니다. 잠깐 리뷰를 해보면 We have already defined the probability distribution function large PDF of an random variable. For extreme, if large x and y are random variables, then their distribution function are defined as distribution function입니다. Now we define the probability that both x not larger than x, y not larger than small y, as the joint probability distribution function of x and y, large fx, y 이렇게 만들죠. If the meaning is clear from the context, we often use shorthand notation fxy to represent the distribution function f, large xy, small x, y. Some properties of the joint distribution function are fxy 이렇고 fx 이렇고 FAC는 FBD, if A 이런 경우에는 이렇게 정해요. 이건 왜 되는가 하면은 BD가 이 전체를 말이죠. 요 전체로 하죠. 이 전체에서 BC 이 부분 빼고 AD 이 부분 빼면 이 부분이 중복으로 빼줬기 때문에 더 해줘야 돼요. FAC. Now note that equation 61 and 62 that the distribution of RA can be obtained from the joint distribution function. fx 무한대 fx f 무한대 x가 무한 가져가는 fy. When the distribution function for a single RA is obtained this way, it is called marginal distribution function. Joint distributed density function, joint PD, small PDF, small fxy는 2.2번 형태로 되죠. As before, we often use shorthand notation fxy to represent the density function f, large xy, small x, 이렇게 정의되고 fxy는 fx는 fy는 Note that equation 61, 65 that the PDF joint probability density function of one RV can be obtained from the joint probability density function when the PDF for a single RV is obtained this way. It is called the marginal probability density function. Computing the expected value of function g data of two RVs is similar to computing expected value of a function of a single RV. Statistical independence. Recall, two events are independent if the occurrence of one event has no effect on the probability of occurrence of the other event. We extend this to say that RVs large x and y are independent if they satisfy the following relation. 이렇게 되면 From our definition of a joint distribution of density function, we see that this implies 이렇게 돼요. The central limit theorem says that the sum of independent RVs tend toward the Gaussian RV regardless of the PD of individual RVs that contribute to the sum. This is why so many RVs in nature seem to have a Gaussian distribution. Many RVs in nature are actually the sum of many individual and independent RVs. For example, the high temperature on any given day and any given location tends to follow a Gaussian distribution. This is because the high temperature is affected by clouds, precipitation, wind, air pressure, and humidity, and other factors. Each of these factors, in turn, determined by other random factors. The combination of many independent random variables determines the high temperature, which is Gaussian PDF. Control limit theorem. In probability theory, the central limit theorem established that in many situations, when independent random variables summing up. The properly normalized sum tends to toward a normal distribution. Normal distribution equal Gaussian distribution. Even if the original values themselves are not normally distributed. If large x1, large x2, large xn are random samples drawn from a population with overall mean mu and the finite variance sigma scale. If xn bar is a sample mean over the first n samples, then the limiting from the distribution sample mean 처음 n 개 샘플에 대한 sample mean 마이너스 mu 시그마 x 루트 n분의 시그마 is a standard normal distribution. We define covariance of two scalars always I, x, and y. 코베리언스는 이렇게 표현되는데 요거 전개하면은 쭉쭉쭉 요 하면 요 나오고 이렇게 돼요. 예. We define correlation coefficient of two scalar always x and y에서 이 correlation coefficient는 코베리언스 시그마 x, y를 그 스탠다드 deviation. sigma x, sigma x, y. The correlation coefficient is a normalized measurement of independence between two always x and y. If an x and y are independent, then rho equals 0. Although the converse is not necessarily true. If y is a linear function of x, then rho equal plus minus 1. y equal ax plus b, a가 제로가 아니고 ab는 리얼이다. 그러면 이걸 쭉 전개해 봅시다. 쭉 전개하면 되고 이건 사라지고 이렇게 돼요. 그럼 시그마 x 스퀘어는 이거죠. 그리고 시그마 x가 이렇게 되죠. 그럼 73, 72에 넣으면 a 시그마 x, 시그마 y 작성도 쭉 전개해 봅시다. 쭉 전개해서 b 스퀘어 날라가고 여기 요것도 날라가고. 여러분 a 작성 x 스퀘어. 시그마는 아마 a는 절대值하면 돼요. 74, 75로 넣으면 시그마 x, 시그마 y분의 시그마 x는 시그마 x는 a 시그마 x 작성. 시그마 x, y는 a 시그마 x 작성. 시그마 x 이렇게 돼요. 플러스 마이너스 1이 돼요. 네, 플러스 마이너스 1. 리니어. 그 코피션트 코릴레이션 코피션트가 플러스 마이너스 1이 되는 리니어 펑션이에요. 예, 이상입니다. 다음 시간에는 또 코릴레이션 얘기를 계속 이어가겠습니다. 감사합니다.